Assalamualaikum. Hi everyone. So this is your video for part 2 of 2.3. Okay, we are still in 2.3 Hess's law and we still have the same learning outcome. Okay, so in this video, I'm going to explain step by step on the extra examples that I gave you. So if you need guidance, so you can play this video step by step, or if you just want to compare your answer, so you can just skip the steps and go straight away for the answer. Okay, let's start now. So example calculation to find delta H, try your own one. Okay, this is example 1. So the enthalpies of combustion of carbon and carbon monoxide are given below. Okay, so the question gives us two thermochemical equation, delta H combustion of carbon and carbon monoxide. So by using the energy cycle method, calculate the heat change for the following reaction. So for this question, okay, it already gives us what is the target equation. So we can skip step 1 where we need to write down the target equation. Okay, so now let's take a look on how to solve this question. We're going to use method 2, energy cycle method. So let's go. Okay, so let's answer this question. So actually for example 1, the question already gave us so many information and we can skip a few steps. So the first step that we can skip is coming out with the what we call as the target equation. Why? Because the question already gave us the target equation. So your job right now is just to construct the energy cycle diagram. Why? Because the thermochemical equation is also being done for you. It's given here. So we don't have to write down. Okay, so let me just label over here. So this is equation 1, this is equation 2, to make it easier for me to explain. Okay, now start with the target equation over here. Okay, so 2 carbon, so I put it around here. Okay, so 2 carbon solid plus O2 gas to produce 2 CO gas. Okay, so now let's so let me change to another color. Okay, so let's start with, you just choose any of this that you want and then just do it in which direction that you think is easy for you. Okay, so let's say I want to start with carbon. Okay, so the equation that has carbon is equation 1. Okay, so for equation 1, carbon plus oxygen to produce carbon dioxide. So I don't have carbon dioxide in my equation. Okay, so maybe I want to start with CO. So CO plus half O2 to produce carbon dioxide as well. Okay, so meaning both of this equation will produce carbon dioxide. So it doesn't matter in which one did I choose first. So let's say I want to choose the first equation. Okay, so since the carbon is here and the number of carbon here is 2, meaning what I need to do is equation 1, the whole equation, I must times it by 2. Okay, so 2 carbon plus 2 oxygen. Okay, and then we'll produce 2 carbon dioxide gas. Make sure with all the phases. Okay, so delta H, so this one, let me put it as delta H1. Okay, since I did not change this, the arrow, so the sign is the same, negative, it's just the magnitude, the value times by 2. So I will get negative 786 kilojoule. So that's the first one. The next one, So we will do the next one for the second equation, okay, for CO. So 2CO. So 2CO plus half O2 to produce carbon dioxide. Okay, so you can do the arrow from CO here, from CO up here towards carbon dioxide down here. Okay, so draw your arrow like this, and then in the equation, since it's 2 carbon dioxide, so the whole equation 2 over here, we also times it by 2. Okay, so 2CO plus O2 gas to produce 2 carbon dioxide. And then the delta H, I put as delta H2. Okay, the value will be negative 248 times 2, negative 496 kilojoule. Okay, and then the one that we want to find here is our okay, since the question just mentioned delta H, heat change. Okay, so we just put as general delta H reaction. Okay, so this will be our energy cycle diagram. Okay, so let me put it up here so that we can do the calculation down there. So after we did our energy cycle diagram, so analyze it. Okay, try to find the arrow that follows clockwise and the arrow that follow anti-clockwise. So the one that follow clockwise is this one. Okay, this part follow clockwise, meaning it will be on the same side. So I put it down here. So delta H reaction plus delta H2. Okay, and then the counter clockwise, okay, anti-clockwise. Okay, this one. So as you can see, we only have it for delta H1. So delta H reaction plus delta H2 equals to delta H1. Okay, so just substitute all the values that we have. So delta H reaction still as delta H reaction. Delta H2 is negative 496 equals to delta H1 negative 786. So rearrange. Okay, so we will get negative 786 plus 496. So the delta H reaction for this question will be negative 290 kilojoule per mole. Okay, so again, please make sure that you put it as kilojoule per mole as the final answer. Okay, the standard heat combustion of 1,3-butadiene, butane and hydrogen are negative 2540.2 kilojoule, negative 2877.6 kilojoule and negative 285.8 kilojoule respectively. So by using the algebraic method and the data given, calculate the heat change for the following reaction. Okay, so for this question, it's the question already gave you our target equation. Okay, so simple. Step 1, settle. Okay, and then step 2 for algebraic method is where we write down all the thermochemical equation. So we need to write down the thermochemical equation for other components because it only gave us the values. Okay, and then please take note that the information given to us is standard heat combustion, meaning it's delta H not C, standard. Okay, so this question has specifically asked you for the algebraic method, so do the algebraic method. But if let's say the question just ask by using the data, calculate heat change. Okay, so if it doesn't mention any specific method, so you can choose either you want to use method 1, algebraic method, or method 2, energy cycle method. Okay, for this question, for example 2, method 3, okay, delta H reaction, delta H knot reaction from delta H knot formation is not suitable. Why? Okay, so like I mentioned in the previous video, to use that method, the information that you need to have is delta H knot formation. Since we don't have delta H knot formation over here, there's no delta H knot formation. The one that we have is standard heat combustion delta H knot C. So method 3 is not suitable. So let's solve this question by using method 1, algebraic method. So let's go. Okay, since we do have the target equation over here, so what you need to write down right now is all of these terms. So we need to write down the equation for combustion of 1,3-butadiene, combustion of butane, and combustion of hydrogen. Okay, so since it's a combustion reaction, so recall back the definition of delta H combustion. Okay, standard combustion. So heat released when 1 mole of compound is burned completely in oxygen, in excess oxygen. So since it is standard, so at standard condition of 25 degrees Celsius and 1 atm pressure. Okay, so that's the definition. So by understanding the definition, you can write down the equation. Okay, so let's start with the first equation. Okay, for butadiene, so 1 mole of butadiene, so 4C4H6 already given to you as gas, plus oxygen. Okay, plus oxygen over here, oxygen gas. So the product will always be carbon dioxide, okay, plus H2O, liquid. So balance the equation, so 4 carbon dioxide over here, okay, and then 3 H2O to get 6 hydrogens, and balance the oxygen. So oxygen 8 plus 3, 11, so 11 over 2. And then don't forget the delta H value. Okay, so let me take this here, so I have some space to write down over here. So delta H not C is equals to, for 1,3-butadiene is this one. Negative 2540.2 kilojoule. Okay, so make sure you write all the numbers. Okay, and please have enough space to write down. So that's the first one. Next, the second equation, okay, is for butane. Okay, so for butane, H10 gas plus oxygen, gas to produce carbon dioxide and H2O. Okay, so balance the equation, so 4 carbon dioxide and then 5 H2O and oxygen 13, so 13 over 2 oxygen. So delta H naught C for butane, okay, the value is this one, so negative 2877.6. so write down that value, negative 2877.6 kilojoule. And the last one, okay, for combustion of hydrogen. Okay, so for hydrogen, H2 gas, okay, plus oxygen gas, the product that you will get is H2O. Okay, so H2O over here and put it as liquid, so since it is at standard condition. Okay, so balance the equation. Hydrogen is already balanced. Oxygen. So on the right hand side, oxygen is 1, so will be half oxygen. Okay, so delta H not C for combustion of hydrogen is negative here, negative 285.8 kilojoule. Okay, so once we have all the thermochemical equations here, we can start with the algebraic method. Okay, so let's do it one by one. So let me change into another color pen. Okay, so let me use the black one. Okay, no, let me use red. Okay, now, so this is our target equation. So check one by one. So let's start with C4H6. So which equation has C4H6? Equation number 1. So how many 1,3-butadiene that we need? Only 1. Okay, and make sure that it's on the same side. We want on the target. So let me put this as target. Okay, butadiene is on the left hand side. So from equation number 1 is on the left hand side as well. So you don't have to change anything, okay, about equation 1. So just write equation 1 as it is. So C4H6 gas plus half O2 gas to produce 4CO2 gas plus 3H2O liquid, and put the delta H as delta H1. Okay, negative 2540.2 kilojoule. So leave it as it is. Okay, the next one, in the equation I have hydrogen. Okay, so hydrogen is in equation 3. Okay, so what are we going to do with equation 3? So if you look here, the hydrogen is on the left hand side, on the reactant side. On equation 3 is on the reactant side. Okay, settle. Then we need 2 moles of hydrogen on the target equation. But the one that we have is 1 mole. So what you need to do is equation 3 times by 2. So the whole equation here, you will times it by 2. Okay, so write down the equation. Okay, I put the times 2 at the wrong one. So equation 3 here. Okay, times 2. So 2H2 gas plus O2, okay, to produce 2H2O liquid, and put it as delta H2. So since we did not reverse the equation, so it's still negative. It's just that the value is now doubled. So the value will be 571.6 kilojoule. Settle. Okay, the next part is C4H10. Okay, my C is gone. Okay, C4H10 over here. Okay, so on the target equation, C4H10 is on the product side, but on our thermochemical equation here, it's on the reactant side. So we need to reverse this equation. Okay, and then how about the number of moles? So 1 mole, 1 mole. So the only thing that we need to do is just reverse the equation. Okay, so settle equation 2. So 2 reverse. Okay, so once we reverse the equation, it will be 4CO2 gas plus 5H2O liquid, okay, to produce C4H10 gas plus 13/2 oxygen gas, and put as delta H3, and the value right now will be positive 2877.6 kilojoule. Okay, so there we have all the 3 equations. So right now the next step is for us to total this. Okay, so let me make a pretty line. Okay, so add up the two equations. Okay, so cancel all the terms that is the same. Okay, the same term. So check one by one. First, oxygen. Okay, so we have oxygen over here, 11/2 plus 1 oxygen over here. So the total oxygen that we will have is 13/2. So we can cancel this. Okay, next, what else can we cancel? Okay, carbon dioxide, CO2 on the product side and CO2 on the reactant side. So 4. Okay, what else do we have? Water. Okay, so on the left hand side, 5H2O. On the right hand side, 3H2O with another 2H2O. So 3 plus 2. Okay, 5. So since it is 5, so we can cancel this. Okay, so do we have anything else that we can cancel out? Okay, no. So write down all the remaining terms that we have. So C4H6 gas, this one, and then plus 2H2 gas to produce here C4H10. So there we have our target equation, the same as the one given. So meaning here, this will be delta H. Since only heat change for the following reaction, so just put as delta H reaction. Okay, so delta H reaction here will be delta H1 plus delta H2 plus delta H3. Okay, so put here negative 2540.2 plus negative 571.6, okay, plus positive 2877 to 877.6. So our final answer, it will be negative 234.2 kilojoule. And you will leave this one, the final answer over here, as only in kilojoule. Okay, why is that so? Because here we only have delta H reaction and we do not know the reaction refers to 1 mole of what? Okay, is it C4H6 or is it H2? So since this is just a general reaction, okay, without specifically saying 1 mole of what, so that's why the final answer you will leave just in kilojoule. So negative 234.2 kilojoule. So that will be for example 2. So the final example, so the combustion of 4.6 gram ethanol evolve 136.7 kilojoule heat at 25 degrees Celsius and 1 atm pressure. So calculate the standard enthalpy formation of ethanol. Okay, so for this question, the information given to you is delta H naught formation for carbon dioxide and delta H naught formation of H2O. So for this one, we can use the third method. Okay, but this question is not as straightaway as the one that we did before. So now let's take a look on how to solve this question. Okay, we're going to use third method, determining delta H naught reaction from delta H naught formation. Now let's go. So let's start this equation by writing down the target equation. So our target equation, the question give us combustion. Okay, so combustion, and we want to find the standard enthalpy formation of ethanol. Okay, so the target equation that we will write down is not standard enthalpy formation of ethanol, but we're going to write down the combustion. usually the target equation is the reaction. So the reaction is delta H combustion. Okay, so combustion of ethanol, so CH3, CH2, OH. So our ethanol will be liquid, okay, plus oxygen, gas. So combustion will be carbon dioxide, gas plus H2O. Okay, so for this one, so we balance it first. So 2 carbon dioxide, 3 H2O, and 3 oxygen. Okay, we need to write it as a thermochemical equation. Since we want to use the third method, okay, which is I just write it down here. So delta H naught combustion, okay, equals to the sum of delta H naught formation of the reactant, of the product, minus the sum of delta H formation of the reactants. Okay, so this will be the equation that we're going to use. Okay, so you need to make sure that you have the value of delta HC. So I just write it down here because I don't have any space right here. Your thermochemical equation should be in one line, but please make an exception for my video because I don't have much space over here. So delta H naught C. So we need to find what is the value here. So in kilojoule per mole. Okay, what is the value over here? So to find that value, the information that's given to us is this. Okay, the question said that the combustion of 4.6 gram of ethanol evolved 1.36.7 kilojoule of heat. Okay, to find 1 mole of heat release, so we need to use this information. How are you going to use this information? So find first what is the number of mole of ethanol. So number of mole of ethanol from this reaction is 4.6 gram over its molar mass 46 gram per mole. So we have 0.01 mole of ethanol. Okay, so do the stoichiometry, meaning the energy 136.7 kilojoule energy evolved is when 0.01 mole of ethanol is burned. So if 0.01 mole ethanol is burned, it will release 136.7 kilojoule of heat. Okay, so I just put as heat here. So I want it 1 mole. Why do I want 1 mole? Because I want to put it over here, okay, in the delta H naught combustion. Okay, can I take this as delta H naught combustion? Yes. Why? Because the reaction occur at standard condition, 25 degrees Celsius and 1 atm pressure. Okay, so 136.7 times 1 over 0.01. So the value of energy release, the amount of energy release when 1 mole of ethanol is burned is 1,367 kilojoule heat. Okay, heat released. So please bear in mind when I say it is heat released, when you write down inside the thermochemical equation here, you must have the negative sign to show that it is heat released. Over here, if you don't put as negative, it doesn't matter because I already written down here heat release. But in the thermochemical equation, make sure you have the negative sign. So negative 1,367 kilojoule. Okay, so now back to solving the question over here. Okay, so delta H naught C, if I were to elaborate this one, okay, so we need to have delta H naught formation. So the product first, carbon dioxide, okay, and then this value we need to times by 2 because we have 2 carbon dioxide plus 3 delta H not formation of H2O. Okay, H2O over here, and then minus the delta H formation of ethanol. So delta H not formation CH3 CH2OH. So this is the one that we want to find, plus 3 delta H not formation of O2. Okay, so let me highlight the one that we want to find. We need to find this one. Okay, and this is the equation. So once you have all the equation over here, so if you look, we have the information on formation of carbon dioxide, we have the information on formation of H2O. So for formation of oxygen, since oxygen is readily exists in 25 degrees Celsius and 1 atm pressure, so it does not need to be produced, so the delta H formation is 0. Okay, so substitute all the values, all the information that we have. So our delta H not C, okay, the one that we calculate just now is negative 1, okay, negative 1367. Okay, so here 2, okay, carbon dioxide is negative 393.5 plus 3 formation of H2O is negative 285.8. Okay, close. And then minus, so the one that we want to find, okay, delta H not formation of CH3 CH2OH. Make sure you write it as a full term like this, plus 3 oxygen is 0. Okay, let me just put it as square bracket, so it will be the same as our equation up here. So rearrange everything. Okay, rearrange and write down. So the one that we want to find is delta H not formation of CH3 CH2OH. So I just write down the final answer here. You will get as negative 277.4, and then since this is one of the enthalpies that you need to memorize, delta H formation, the definition, so the unit will be kilojoule per mole. So this will be your final answer. Okay. So that's it for example 3. So I hope this video has helped you to improve your calculation on those 3 methods and help you to calculate for all the 3 examples that I give you. Okay, so thank you for listening attentively until the end. So till we meet in the next video. Thank you guys.